Hello, in this lesson we will discuss the properties of logarithms. We will learn how to use logarithmic properties to rewrite, expand, condense, and evaluate logarithmic expressions. These properties are extremely important because they allow us to simplify complicated logarithmic expressions and solve logarithmic equations more efficiently. Let's get started. In this section, we will learn how to use the change of base formula to rewrite and evaluate logarithmic expressions. We will also use properties of logarithms to evaluate or rewrite logarithmic expressions. Next, we will learn how to expand logarithmic expressions. And finally, we will learn how to condense logarithmic expressions and apply logarithms to real-life situations. The change of base formula is used when a calculator cannot directly handle arbitrary bases. Most calculators only have two logarithmic buttons: the common logarithm, which is base 10, and the natural logarithm, which is base e. So when we have a logarithm with a different base, we use the change of base formula. The formula says, for positive real numbers a, b, and x, where a is not equal to 1 and b is not equal to 1, we can rewrite log base a of x as log of base b of x over log of base b of a. We can also specifically change to base 10. Log of base a of x is equal to log of x over log of a. Or to base e, log of base e of x is equal to natural log of x over natural log of a. Notice the pattern. The original base always moves to the denominator. The value stays in the numerator. At the bottom of the slide, we also review the meaning of exponential and logarithmic forms. In exponential form, a to the power n equals b, where a is the base, n is the exponent, and b is the value. In logarithmic form, log of base a of b is equal to n, where a is the base, b is the value, and n is the exponent. Let's look at an example using the change of base formula. We want to evaluate log of base 2 of 12 using common logarithms. Using the formula, log of base 2 of 12 is equal to log of 12 over log of 2. Using a calculator, log of 12 is equal to approximately 1.0792, and log of 2 is equal to approximately 0.3010. Now we divide to get 3.5853. So log of base 2 of 12 is approximately equal to 3.5853. This actual value is approximately 3.58496. So our approximation is very close. Remember, many logarithms are irrational numbers, so calculator results are often approximations. Now let's review the three major logarithmic properties. Assume that a is bigger than 0 and a is not equal to 1, and that u and v are positive real numbers. The first property is a product property. Log of base a of uv is equal to log of base a of u plus log of base a of v, and for natural logarithms, natural log of uv is equal to natural log of u plus natural log of v. The second property is the quotient property. Log of base a of u over v is equal to log of base a of u minus log of base a of v. And similarly, natural log of u over v is equal to natural log of u minus natural log of v. The third property is the power property. Natural log of a of u to the n is equal to n times log of base a of u, and the natural log of u to the power n is equal to n times the natural log of u. One very important warning: there is no property for logarithms involving addition or subtraction inside the logarithm. That means that log of base a of u plus v is not equal to log of base u plus log of base a of u plus log of base a of v. This is a common mistake among students, so be careful. Now let's use logarithmic properties to rewrite expressions. We want to rewrite each logarithm in terms of natural log of 2, and natural log of 3. For part A, natural log of 6, first rewrite 6 as 2 times 3. So, natural log of 6 is equal to natural log of 2 times 3. And using the product property, natural log of 6 is equal to natural log of 2 plus natural log of 3. Now let's look at part B. We have natural log of 2 over 27. And using the quotient property, we get natural log of 2 minus natural log of 27, and we can rewrite 27 as 3 to the power 3. So natural log of 2 minus natural log of 3 to the power 3, and using now the power property, we get natural log of 2 minus 3 times natural log of 3. And this is our final answer. Now let's find the exact value of the log of base 5 of the square root of 5. Let's find the exact value of the log of base 5 of the cube root of 5 without using a calculator. First, rewrite the cube root using a rational exponent. The cube root of 5 is the same thing as 5 raised to the power of 1/3. So the log of base 5 of 5 raised to the 1/3, applying the power property, will give us 1/3 times log of base 5 of 5. And using the identity property, we know that log of base 5 of 5 is equal to 1. So we get 1/3 times 1, which simplifies to 1/3. So the exact value is 1/3. Now let's practice expanding logarithmic expressions. For part A, we have log of base 4 of 5x cubed times y. Using the product property, we can expand this to be log of base 4 of 5 plus log of base 4 of x cubed plus log of base 4 of y. And now applying the power property, we have log of base 4 of 5 plus 3 times log of base 4 of x plus log of base 4 of y. Now let's look at part B. We have natural log of the square root of 3x minus 5 all over 7. We can rewrite the radical using a rational exponent. That means we have the natural log of 3x minus 5 raised to the power 1/2 all over 7. And using the quotient property, we have the natural log of 3x minus 5 raised to the 1/2 power minus natural log of 7. Now applying the power property, we have 1/2 natural log of 3x minus 5 minus natural log of 7, and this is the expanded form. Now let's condense logarithmic expressions into a single logarithm. For part A, we have 1/3 times log of base 2 of x plus log of base 2 of x plus 1. Using the product property, we have 1/3 times log of base 2 of x times x plus 1. And applying the power property, we have log of base 2 of x times x plus 1, all raised to the power 1/3. Finally, we can rewrite this using a radical to get log of base 2 times the cube root of x times x plus 1. Now let's look at part B. We have 2 times the log of x plus 3 minus 2 times the log of x minus 2. We first apply the power property, so we get 2 times the log of x plus 3 minus log of x minus 2 squared. And using the quotient property, we get 2 times the log of x plus 3 over x minus 2 squared. And lastly, applying the power property, we get log of x plus 3 over x minus 2 squared, all squared. And finally simplify, we get log of the log of x plus 3 to the power 2 divided by x minus 2 to the power of 4. And this is the condensed form. There's a lot here, but this will conclude our lesson on properties of logarithms.